Okay, going through everything just one more time. We're busy with finance, which would be in a paper 1, specifically interest and tax. You need to know.
Please return to C6 now. Now go to C6.
The difference between interest and interest rate. You need to know the difference between interest and interest rate. Borrow and invest we looked at the different ideas of compound, accumulate, principal, and accumulated amount. We looked at some examples that we calculated and found the different parts of those things. We looked at what the two different types of interest were. Interest is simple interest is always a one calculation at the beginning. It doesn't matter how many years. It is always one calculation. And then we practice doing it separately and we practice doing it in one equation. And then compound interest is a constant process of calculations. Every time there's a compound, there is a calculation. There's our definitions. Simple interest is based on principal, interest rates, and time period. Compound interest is based on the interest rate, the number of compounds, the time period, and the amount accumulated at every point, not the principal. Our general idea is that principal plus principal times the interest rate is my accumulated amount. Specifically for simple interest, my interest must also be times by the number of years, because every year I accumulate the same amount of interest, so I times it by how many years I am busy with. There we did it separately, year 1, year 2, and we found that a year 3 would also have 575 Rand interest. Okay. Please be very careful. Make sure that you use the percentage sign. If you're going to use whole numbers, else use the decimals. And then we practice that, split and together. Then we looked at hire purchase. It is when we buy items on credit at a shop. Generally, a deposit must be paid, and then the balance is what goes onto the simple interest formula. After you've calculated using the simple interest formula, remember, I don't tell you that it's simple interest. You need to know that hire purchase is simple interest. Then we divide by 24 to get my monthly repayments, and my total cost would be all money spent on the item, the deposit plus the loan plus the interest. Our example that we dealt with was a laptop, which we paid a 15% deposit for, so 15% of the purchase price gave me 1,949 Rand and 85 cents. I had to pay that before I could leave the shop. Then what goes on my loan is after I minus it, and my loan is 11,049 Rand and 15 cents. There's my simple interest formula. 17.25% with the percentage sign over 2 years tells me my accumulated amount, principal plus interest. Dividing by 24 to get my monthly repayment that I would have to pay, but the total cost is my deposit plus accumulated, which is principal and interest. Then we did one example with, or we added insurance, and we did one example by ourselves and we marked it. And then we started looking at compound interest. So let's slow down a little bit and re-look at compound interest. So a reminder, simple interest was one calculation at the beginning of the year. We only needed to know the interest rate, how much the loan was for, and how many years I'm going to take to pay it off. That's all we needed to know. And we could put it into this and we could solve. Okay? But if we look at those definitions, we can see that compound interest is at regular intervals. Every time there is a compound, there is a calculation. So that's my next slide. So we still follow the general idea of principal plus principal times interest rate. But now it is not the principal anymore. It becomes my previous answer from the previous calculation. So we highlighted this part here, where every time a compound is performed, a new calculation has to be performed. And that's when we did that thing on the board, where we decided compounded annually meant once per year, so one calculation per year. 2 years would mean 2 calculations. We went, let's say monthly. That means for the year there would be 12 calculations, but for 2 years it would be 12 plus 12, 24 calculations. We also looked at quarterly, which would be 4 times a year. So 3 years would be 4 plus 4 plus 4 calculations. And every time we took my previous calculations answer to get the next calculation. And then we started breaking it down, and I remember correcting those numbers. And it's the same one, just highlighting the fact that we start with the previous year's answer. And then I asked you, what would my year 3's answer look like? How would I write year 3? What would I start off with? Peace? Can you see this cookie on the board when it's too thin? Can you see it? Okay. And then what would that number be in that bracket? Would it be 22,450? What would we start with? The same amount from the previous calculation. I'm using the percentage sign. So in my calculator, I also use the percentage sign. Two five 200.13 plus 200.13 times 12, 25 shift bracket, give me the percent. That is 28,000. 287 rand and 15 cents. So it's 14593. Money is rounded to 2 decimal places, so it's 15. So I stated again, since the starting amount changes every time, we need to do all calculations separately. Even though a formula does exist to do this quickly, we don't teach it in Maths Literacy because they will not mark it in matric. They don't even bother looking at the question if you use the formula. So I'm not even going to remind you of what it is because we need to get used to doing it this way. Okay, so I'm going to give you one to try. So I tell you it's compounded annually, so how many calculations per year? Every year is how many calculations? Only one, but how many total? There will be 3 because it's 3 years. Peace. Oh, do you have this calculator? Take it out. Can you see my calculator? Okay, press shift. Okay, the middle bracket, the one next to E and G, and that gives you a percentage. Okay, so you would put your 12.25 shift next to E and G to get your percentage. So you put it after your number. And let's say you times it by 100. That will give you your answer of what, okay, 100 is a bad idea. Make it 1,000, and that will give you your answer. So 12.25% of 1,000 is 122,5. So the percentage is after the number. Okay, back to our slideshow so we can actually do our example. Okay, who's so busy? Okay, so year one, we start with 12,250 Rand. And my interest for that year, since it's compounded annually, it's one calculation for year one. 12,250 times 10,25%. So let me just check that my amounts are actually correct. 13505, and I rounded off to 6. I did not round off. I kept the 625 because that's going to give me my most accurate answer at the end. So if you did round off, you're going to be a few cents off every step of the way. Okay, but I prefer that you would only round off at the end in a test. So make a note about that, please. Only round off at the end. Year two now starts with that amount, including those extra decimals. 13,505,625, and in my brackets, plus 13,505,625 again times the same interest rate, 10.25%. It's compounded annually, so it's only one calculation for year two. Adding that together, I get 14,889 Rand, 95156. So I kept the decimals, and I start that for year three. Only one calculation for that year, 14,889 Rand, 95156, plus in the brackets 14,889 Rand, 95156 times 10.25%. And since this is my last answer, I now go and round off to two decimal places of 16,416 Rand and 17 cents. Any questions? Anyone got stuck along the way, other than the few rounding errors along that you guys might have made? So my question to you now is, how much interest will I gain on that investment? Or how much interest did I gain on that investment over 3 years? I see some of you going to your calculators. That's good. That's exactly what I'm wanting you to do. Someone give me an answer. Tell me what they did. Peace. Say again, how much? So how did you get such a big number if I ended off with 16,416,17 minus 12,250? Kelly? There we go. But Peace, your thinking is perfect. I just think you typed it wrong into the calculator. We are taking this final accumulated amount, minusing the starting amount. So my final accumulated amount minus my starting amount is how much interest I gained in those 3 years in total. Okay, so when you do your worksheet next week, I will throw in some additional compounds and we will also do one or two more since we have the time. Okay, what I do want to look at, what effect does simple interest have compared to compound interest? So let's say I take exactly the same amount of 100,000 Rand at exactly the same interest of 13.5% per annum and the same time period over 2 years, okay? I want to calculate using simple interest and I want to calculate using compounded annually interest. So how many calculations for the compound per year? Per year is only one. Per year is per one, but a total of 2 calculations. Fantastic. Simple interest I can do in one. Okay, so let's look. Principal is 100,000. Principal times rate times years, 100,000 times, I put it in decimal form, times 2. So I see that I get a total of 127,000 Rand and therefore a 27,000 Rand in interest. Okay, once again, I took the total, 127,000 minus my principal, 100,000. So my interest is 27,000 in interest. Now let's look at my compound. In year 1, 100,000 plus 100,000 times 0,135, giving me a total of 113,500. Now that is my starting point for year 2. 113,500 plus 113,500 times 0,135, giving me a total at the end of the second year of 128,822.50. So now I have 28,822 Rand and 50 cents in interest. So I have more interest accumulated in compound. Now, if I am borrowing money, which of the two am I going to prefer? Simple interest or compound interest? If I'm borrowing money, so I'm going to have to pay back more money. I want simple. I want to pay less in interest. So if you can negotiate a simple interest rate, then you should, if you are borrowing money. But if you are investing money, I'm going to want that compound. I'm going to want to get as much interest as possible. So there's 2 things that I want to do here, which may not come up in grade 10, but can come up in future. So let's just fix that slide. Let's do it on the board instead. So using the same simple interest, I want to split it up because I want to show you. So after year 1, this is the simple interest. I have my 100,000 plus my 100,000 times my interest rate. So since I'm splitting it up, I'm not going to times by 2. That is going to give me 113,500. Year 2, I still start with the principal. What am I doing? What am I doing? So sorry. So interest in year 1 is 13,500. Therefore, the total that I have in year 1 is 113,500. Adding my 100,000. Year 2, my interest is still based on my simple interest principal amount. So in year 2, I still get 13,500, but my total will be the 127. Okay? Can you see that no matter which interest rate you take, my total after the first year is the same? Okay? My total after the first year is exactly the same as compound interest, 113,500. But the fact that this did not change, this principle did not change in year 2, is what leads to the 127,000 in simple interest. But the fact that it does change in year 2 in compound is what leads to the additional interest. So if I had to ask you something like true or false, the first period in both simple interest and compound interest is the equal or is an equal amount. Your answer would be true, because the first year they accumulate exactly the same amount of interest. After that, it's going to start to change. So that's the first thing. My first year interest is the same for both. Year 1 for simple and compound interest will accumulate the same interest. And I'm actually going to change year 1 to period 1. So period 1 for simple interest and compound interest will accumulate the same interest. That was the first note. The second note is when borrowing, we want simple interest if possible. We want simple interest if possible. When investing, okay, we'll do that now. If we can't get simple interest with compound interest and we are borrowing, what factors will lead to the least amount of interest? Any ideas? So the higher my interest rate, the higher my interest in rands, right? So try to get as small interest rate as possible. So if compound interest is compulsory, we want a lowest possible rate, lowest possible interest rate. There's also another factor, and that's got to do with my compounds. The more I compound, the more interest I'm going to be calculating. So I want to have as little compounds as possible when I am borrowing. Okay? So I want to have as little compounds as possible, or at the lowest rate possible. That will ensure that I pay the least amount of interest, because that's what I'm worried about. I want to pay as little extra money as I have to. Okay, so when borrowing, we want simple interest if possible. If it's compound interest, it must be the lowest possible interest rate, or as little compounds as possible. All of this ensures the least amount of interest. Since we are borrowing, we want to pay as little back as possible. Going hand in hand with this compounded, you want to have as few years as possible, or the shortest possible time period. And this is a very nice higher order question. I ask you, what can be done to reduce the interest on that loan? And you will tell me, swap for simple interest if possible. Or you'll tell me, compound interest, the lowest rate possible, the shortest compounds as possible. That's a 4 marker, okay? And remember that you see we have 4 levels of question, and that would be a level 4 question, your most difficult kind of question. Now, when you are investing, you want the opposite of all of this. So now you want to gain money. We have tried to avoid simple interest. We want compound interest. And specifically, we want the highest interest rate possible. We want as many compounds as possible. We want the longest time possible. The longer it sits there, the more interest we will earn on it. So if you invest as soon as you leave school at 18 and you leave it there until you're 65, that will gain a whole lot of interest while you are working, okay? So that you can enjoy your retirement. And this ensures the most amount of interest. You will receive. So I can obviously ask you to calculate, and that will be your most common kind of questions, but I can ask you these kind of higher order thinking questions. So I just want to take a picture because I'm also teaching, this is Odendahl's class. Okay. So while you're writing that down, we'll write an example down that we're going to try. Okay, so here is my question, okay? And this is something that we would keep, at least I would keep for grade 11, but I will put 1 or 2 into your worksheet next week so that you can practice. Now, when I have a question like this, let's first read it. It says 250,000 Rand is borrowed at 11.5% interest per annum, compounded quarterly for 2 years. Okay. How many calculations per 1 year? 4. So how many calculations am I going to have over those 2 years? 8. Okay, so I would have to, this would never be a test question because it's way too many calculations, but I would have 4 calculations for year 1, and I would have 4 calculations for year 2. Okay. So I would go starting and getting my first compound, 250,000 plus 250,000 times my interest rate. But now, this is where the trick comes in. I said 11.5% per annum. So all my interest for the year has to be 11.5%. It's not per compound. So if I'm going per annum 11.5%, how much percentage am I going to get in one compound? Well, quarterly is a quarter of a year, so I need to get quarter of the interest. So I would have my 11.5% and I would divide it by 4. So it is my full year divided by 4, but my interest is also divided by 4. And that I can calculate. And I think, Jack, you did it already. What's the answer? 2.875. Is the percentage. So you went 11.5% divided by 4. Okay, so you can, like Jack has done, he's gotten the simplified answer, which is perfect, but you can also just leave it as 11.5 over 4 on your calculator. Okay, so you said it was 2.5. So you can say 2.5 in compound 1, 2.5 in compound 2, 2.5 in compound 3, 2.5 in compound 4. And all together, so it should actually be 2.75, I think. 875. So 2.875, 2.875, 2.875, 2.875 gives you your full 11.5% interest for the year. Okay? But your compound has to be a quarter, just like your year is split up into quarters. So that's why I said yesterday, be very careful that we are talking about interest per annum. But I would never give you a test that is not per annum. Definitely not in grade 10. Even though it was given last year, I didn't teach grade 10 last year, so I never got to see those exams. But we will go through it last year, the last year's one, the next time I see you, just to see. It's actually not that difficult, but I feel like it's for grade 10, it's a bit too much. Okay, so what is my final answer after year 1 with the division of 4? Because I've lost my calculator. Oh, here it is. I get 257,187,50. And just like before, my second compound starts with the amount from my previous compound. So now I'm going to start with 257,187,50 plus 257,187,50 times, and you can use the 2,875 immediately if you wanted to, or we can leave it by dividing by 4. So before, we were technically dividing by the number 1 because we were compounding once a year. So 11.5% divided by 1 is still 1. So what I'm dividing by is the number of compounds in a year. And then I have the calculations per year, and I have to do those calculations for every year that I have the investment or the loan. So I'm quickly going to do it. It's going to take a few minutes because it is 8 calculations. So according to my calculations, my second year, I now have 2, 6, 4, 5, 8, 1 with a whole lot of decimals, 6406. I'll start writing a bit more further in the margin. 2, 6, 4, 5, 8, 1, comma, 6406. Like I said, I would not ask this many calculations because that's just way too many marks on exactly the same thought process. Sorry, 0.5 divided by 4. Okay, this is still percentage. I mustn't forget my percentage. And I get 272,188,3628. And my fourth compound, but still, all of this is still the first year. This is all still year 1. Okay, I'm going to start off with that previous amount. Calculate the interest on that previous amount. Times it by my 11.5% over 4. Giving me 280,013,7782. So only now am I done with all my calculations for year 1. And I would have to repeat it for the next year's first compound. So I would call it compound 5 because it is my next compound. But the next of these is now in my second year. So compound 5 starts with that 280,013,7782. Still timesing by the 11.5% over 4 because my interest rate did not change. My number of compounds did not change. My answer there is 288,064,1743. I'm running out of space. Compound 6 starts with 288,064,1743 plus 288,064,1743 times the 11.5% over 4.
Attention please, premises fund of Easthazen's grade 11 class, go to B110 for grade 3. Mrs. Fund of Easthazen's grade 11 class to B110.
Giving me 2, 9, 6, 3, 4, 6. Can you see why we start using computers for these things? Okay. But the computer is only as good as what we understand the capability and what is actually happening. So this is 2 more to go. And I'm also actually cheating when I do the calculation on my calculator. I'm not typing the whole thing in.
Please also, Ms. Windgar's class 2, please go to B109. To Mrs. Stussen, Ms. Windgar's class to B109.
And my last one I'm about to start. It's my 8th compound, my 4th calculation in year 2, my 8th total calculation.
Sorry, Groves class to B9. Not B8, it's Groves class to B9.
And just to show you what my final answer is, my final answer is 313,630 and 86 cents. And that is what compound is. Okay. Today's Friday. Wow. Okay, so I will send those worksheets on the group over the weekend sometime. Please, please, please practice. Okay, and ask questions if you need to ask questions. Let's stand, please, grade 10s.